is it number 2? No. Yeah.
Yep.
Okay.
So when you get
Oh yeah. I got 0 is less than x is less than 8/9.
and so I don't know if that will be enough or if you need any more. Let me just copy that. Let's just check. What did they do? So b squared minus 4ac. So they did a sketch of it when k is 0, which is impossible, so no real roots. So they just went about solving it, I suppose. Okay, so you can't use your calculator. So for this last bit, they wanted you to solve it quadratically. So you could do it equals 0. You could sketch what the graph looks like, and you would show like it's either equal to 0 or it's equal to 8/9. Those would be the two answers. And then when is the graph here less than 0?
On the left.
It's greater than 0. It's increasing over there. When is the graph less than 0?
So the y-axis.
Yeah. When is the y value less than 0?
Like on the right when it's under the x-axis.
Yes. And in terms of k, how would you describe it?
8/9.
Between 8/9 and
0.
Yes. So when k is between 0 and 8/9, and that's what we got, when k is between 0 and 8/9. So I suppose you could just solve it quadratically. So just it equals 0. You get the two roots, do a little sketch, and say that's it. Oh, I'd like to look at the exam questions though to make sure for that one. Speaking of whom, so this is 7D. I want to see if there are year 1 pure practice. This one. So this was 7.4. 7.4. I'll just see. Okay. But these won't. They might not have the answers. But we'll see. Okay, how do we do question 5?
Would you set it as equal to 0?
Yes.
And then can you factorize it?
Yeah, how would you factorize it?
On the calculator.
That's the best answer I've heard.
It's got, the calculator says like 3 plus that I thing.
Press equals for the minimum or maximum. I think minimum.
The minimum is 3.
So question 5. Yeah, the minimum. What's the coordinates of the minimum?
3, 1.
3, 1.
Yeah.
What is question 5 in completed square form?
X minus 3 squared minus 9 plus 10. So, is that
What is minus 9 plus 10?
1?
Yes. And so there's your 3, there's your 1.
Oh, right, yeah.
So that is greater than 0. What do you know about all possible values of x minus 3 squared? Or anything squared?
It has to be positive.
Or it could be 0.
Is equal to or bigger than 0.
Yeah, so I'll just have to do them separately. I misplaced my pen. I teach this cheeky girl. I think she accidentally took it. X minus 3 squared is greater than or equal to 0. Therefore, x minus 3 squared plus 1. What do you know about x minus 3 squared plus 1?
Well, so if the square makes it equal to or bigger than 0, but then the plus 1 like makes sure that it's like equal to 1 or bigger than 1, so it has to be bigger than 0.
Yes. And so for those ones you use completing the square. The quick way of which is the minimum or maximum with the solver, if you can remember that, or you can just complete the square. So the square bracket is always greater than or equal to 0. Therefore, the square bracket plus some positive number will definitely be bigger than 0 for all values. Oh, checking for updates. Why do you do this to me? Okay, any questions about that one? I think you're fine. How do you do question 6?
Expand them out.
Yes, and in the second bracket you have to subtract it, so in there you're going to have minus minus. What answer are you supposed to get if you've done it correctly?
4xy.
And so by gum, if you don't get that and you're not sure why, that's going to be your final answer.
Yeah.
Examiners aren't looking too closely at that. Prove that the difference between the squares. Okay, here you go. This is the stuff you were asking about. Okay, how do we do question 7? I greatly regret looking at the exam questions.
So you have to do like n squared and n plus 1 squared because then they're consecutive.
There you go. So n squared. Sorry.
Wait, you know how it says two consecutive odd numbers? Does that mean that it would be like 5 and 7?
How do you represent an odd number algebraically?
I'm not sure.
How do you represent an even number algebraically?
Like if you put 2n.
Yep. And so what would be an odd number if 2n is an even number?
Just n.
So half of 4, let's say half of 8 is 4. So halving it doesn't make it odd.
Oh, 2n plus 1.
Yep. And so what would be the next
2n plus, is it going to be 2n plus 3?
Well done. And so that's the square of that. And what do you do with these two?
Minus.
Yeah. And how do you show that something is a multiple of 8?
If it has 8 in front of it.
Yes. And how would you make it have an 8 in front of it?
If you expand the brackets, maybe.
Yes. Okay. So you'd fully expand this. What's 2n squared?
4n squared.
And what is 4n squared plus 4n squared?
8n squared.
Yes. 4n squared plus 4n squared. So that's going to be 8n squared plus... Oh, subtracting actually. That won't be there. It'll be subtracted. Minus 4n. Oh, better. Okay. So the first bracket... Sorry, there's just a little trick to this that we have to do. 4n squared plus 4n plus 1, and then it is minus 4n squared plus 12n plus 9. Okay, so what do you get for that one?
So 0n squared minus 8n minus 8.
Yeah. And how do you show that that's a multiple of 8? Or what do you do?
Divide it by 8.
Factorize 8 out.
Oh.
What do you get when you factorize out 8?
Yeah. Do you put a minus then, or just a minus then? Or do you put minus then?
Just factorize out 8.
Minus n minus 1.
Yes. So if you'd gotten like minus a half, then it's not a factor. But they're whole numbers, and so therefore a multiple of 8. Yeah, so you have to factorize out the multiple to show that it's a multiple. You don't divide by it. Any questions about that?
No.
Okay. I suppose you could in a way, but just stick to that one. Oy, oy, oy. Okay. Let us do question 8. How do we do this? Oh, I'm making a mistake again.
So is it going to be 2n plus 1 cubed minus 2n plus 1 squared?
1 cubed minus 2n plus 1 squared. Yes, and what do you know about your answer? How will you actually prove that it is even?
If you can factorize 2 out?
Yes. Fully expand, fully simplify, factorize out 2. Let's put a little blank bracket there. Therefore even. taking this to the nth degree. Let's try question 9.
So if it has no real roots, then b squared minus 4ac is less than 0.
Yep.
And then, so it would be k minus 3, k minus 3 squared minus 4 brackets x brackets 3 minus 2k is less than 0. So,
hold on, 4 bracket.
1.
Yes. Less than 0. Okay.
So we'd get k squared minus 3k minus 3k. So k squared minus 6k plus 9.
Okay.
Minus 12 plus 8k.
Okay. What is next?
We can simplify it, so k squared plus 2k minus 3 is less than 0. And then would we factorize that? If it's set it equal to 0, and then we can factorize that.
Okay.
So then we'd get, wait, I'm just going to type it. So we get k minus 1 and k plus 3.
Okay.
And that means that the k is equal to 1 or k is equal to minus 3.
So k equals 1. K equals minus 3. What's next?
Oh, we have to draw a graph.
Yep.
And 1 and minus 3 are the roots.
Mm-hmm.
So, and we need the y-intercept. What would the y be?
Y-intercept is minus 3.
Why?
That's when k is 0. It's like with x.
Oh, when x is 0.
Okay. So when is k squared plus 2k minus 3 less than 0?
Sorry, can you say that again?
So we want when k squared plus 2k minus 3 is less than 0.
When k is equal to 1 or minus 3. So do I substitute that into each one?
No, that's when it's equal to 0. Why did we draw the graph?
So yeah, we could highlight the inequality.
Okay, highlight it.
Well, I know what it's meant to be, but
this is the important bit here. So you simplified it to this, and you sketched it.
Yeah.
So we graphed k squared plus 2k minus 3. where on the graph is k squared plus 2k minus 3 less than 0?
Under the x-axis.
Yep.
So between -3 and 1.
Yes. So, yep. And therefore?
Therefore, k does satisfy the inequality.
Yes. Between -3 and 1 in terms of k. And you would just say it. Yeah. You would just say -3 is less than k is less than 1. Therefore, I don't think you need a step before that. Just, you can just help us by looking at it. Any questions there?
No.
So for these ones, b squared minus 4ac, sometimes it'll be greater than 0, so it'll be when it's above the x-axis, and you just say it in terms of k. Then you just sketch it, sorry. Okay, next one, methods of proof. Did I skip past it? I did. Methods of proof. Okay, how do you feel about that stuff? Mathematical proof.
Okay.
Grandiose. Methods of proof. Here we go. Proof by exhaustion. So you can just literally try every possibility. You can prove that the sum of two consecutive square numbers between 100 and 200 is an odd number. So the square numbers between 100 and 200 are these four numbers. There's only four numbers. So you could just add all four to each other in all possible combinations and permutations and show that you always get an odd number.
Yeah.
So that's exhaustion. It sure is. Okay, how do we do this thing?
So how would I start?
Express all possible numbers algebraically.
So n squared.
Yeah. Well, how would you express every even number?
2n squared.
How would you express every odd number?
2n plus 1.
And so it's either going to be 2n squared or 2n plus 1 squared, because every number is either even or odd. And so that gets all of them. Okay, so try 2n squared first.
Oh, so it becomes 4n squared.
So that one is 4n squared.
And that's a multiple of 4 because we can factorize it out.
So factorize it out.
4 brackets n squared.
You might not have to, but I'm not taking any chances. And the other one
is equal to 4n squared plus 4n plus 1. So you can factorize so 4 brackets n squared plus n, close brackets, plus 1. Therefore, it's a multiple of 4 plus 1 makes it 1 more than a multiple of 4.
Yes. And therefore you have proven it. Great. Any questions about that?
Wait, so you only have to do it to show an odd and an even number, and that proves all square numbers?
What other type of number is there? There's odd, there's even.
Yeah.
Is there any other type of number?
No.
No, there isn't. Therefore, you've shown it for all possible numbers.
Okay.
Therefore, 1 more than a multiple of 4. Kind of tell a lie actually. 0. 0 is neither odd nor even. So is 0? 0 is a special case. A multiple of 4 or 1 more than a multiple of 4. 0 is 0 a multiple of 4? I suppose 4 times 0. Maybe that just goes without saying. For even numbers, 2n squared is 4n. For odd numbers, 2n plus 1 squared, 4n, n plus 1. So they factorize out 4n. I just factorize out 4. Just like they did here. All integers are either odd or even. So all square numbers are either a multiple of 4 or 1 more than a multiple of 4. Yeah, all integers are either odd or even. Any questions there?
No.
That's pretty common, where you just do one as odd, one as even. Okay, proof by counterexample. Prove that the following statement is not true. The sum of two consecutive prime numbers is always even.
How do we write a prime number?
You could just find any counterexample, so you wouldn't have to write anything anything algebraically.
Oh right, yeah. So
if you can find any counterexample, if you can prove them wrong, then you win.
So 5 plus 7. That's 12.
That's odd plus odd. So that's Is there a very special prime number?
1.
1's not prime. Prime number has two factors. 1 has a repeated factor, I suppose.
2.
Yep.
So you could do 2 plus 7, which is 9, which shows
Are
the state.
2 and 7 consecutive?
Oh, I forgot about that. 2 plus 5.
2 and 5 are not consecutive prime numbers.
2 and 3.
There you go.
Which makes 5, which is an odd number, so the statement is false.
Yes. Bye. Okay, great. Therefore false. So counterexample, just find any counterexample. 5 is odd, so the statement is not true. Okay, but why? Why must they mock me? Okay, how about this thing?
So can I just make up any?
That would be proof by exhaustion. You would have to show every possible number. So you'd spend forever doing that.
So do we... It's already like in algebra though.
Add the fractions.
Add them.
Yep.
How?
GCSE algebraic fractions. get a common denominator?
Yeah, but that doesn't. Oh. So we have to times x over y by y over x. So we get xy plus xy over xy plus xy over xy.
Okay, and how do you add fractions?
2xy
Yep.
over 2xy. Oh, so you
You
cancel
what do they cancel to be?
the xy's.
So what remains?
2
Yes.
over
Say it again.
2.
Yep. And is 2 greater than or equal to 2?
Yes.
Yes. How about B?
So we could do x as minus 2 and y as minus 3. No. And y is minus 2 over minus 3 plus minus 3 over minus 2. That one doesn't work. 4 minus 4 sake.
Is there a special type of not positive number?
What do you mean?
Is there a very special type of number that is not positive?
0. Is 0
Bingo.
positive? Oh.
0 is not positive.
0 is like neutral, right?
If you like.
So we could do 0 over plus. Wait, what am I meant to type in?
Let's say x. Oh, hang on. X can't be 0 because then you'd be dividing by 0.
Yeah, because it said maths error.
To show this is not true when x and y are not both positive. Let's say a half and minus 1.
If yeah, okay. So I just did what you said about one negative and one positive. So I did minus 10 and 2, and then you get minus 5.2, which is less than 2. So that shows that the statement, the thing is wrong.
What was it? X equals 10, y equals minus 2?
The other way around, minus 10 and positive 2. But I don't think it's
Yeah, that'll work. So we found a counterexample. One is positive, one is negative. I think if they were both negative, it wouldn't work. Yeah, one is positive, one is negative. Yep. And then part A. What was part A? You add the two together. You did not do that properly at all. I gave you way too much benefit of the doubt. First one, x over y. So the common denominator is xy.
yeah.
What you have? So what did you multiply the bottom of the first one by to get that?
I thought that it was by y over x. So
What
then the top in
what
it.
did you multiply the bottom part by?
X.
And so what must you multiply the top part by?
X.
Yes.
So x squared
Yep.
minus y squared.
Plus, I believe.
Pardon?
Plus y squared, I believe.
Oh yeah, sorry. And is that all over xy?
Yeah.
So then I'm not sure.
Let's see. Over x, y. So that's x squared plus y squared all over x, y. Times both sides by x, y, perhaps.
What do you mean, sorry?
So it is, that is equal, sorry, greater than or equal to 2. So if you times both sides by xy,
2xy, and you get rid of the denominator on the other side.
yeah. And what is next?
So then, is it because there's two square numbers that it has to be like
Make it 0 on one side.
on what side? Sorry.
Oh, maybe you don't. Sorry, I was going to say we solve it, but maybe you don't. I was going to say make this minus that is greater than or equal to 0. And then just solve it. Is that as easy as I thought, though? Oh, that's what you do. Oh, it factorizes. So this here.
Yeah.
Oh, yeah, I suppose if you put the minus 2xy in the middle. In the middle. And then it will factorize.
I'm not sure that I follow.
So you know how we... Okay, so we okay with that one? So you know how we multiplied through by xy, by the denominator?
Yeah.
Okay, so that gave us that. So far, so good?
Yeah, and then we minus it and put it on the other side.
Yep. And then, if we put it in the middle, so we just moved it.
Yeah.
Anything you notice there? If we put it in the middle, you can factorize them into two different brackets.
How?
It will be x minus y, x minus y. What's another way of writing that?
Is that the difference of two squares?
No, that would be 1 is plus 1 is minus.
Oh.
This is the same thing twice.
Oh yeah, so you get x. Oh yeah, okay.
So it's that squared greater than or equal to 0. And what next?
Because it's squared, it has to be.
Yes. That's a good point. Therefore greater than or equal to 2?
Yeah.
2. Oh, yeah, that's very true. What did they do? So, therefore, the whole thing is greater than 0. This step is valid because x and y are both positive. Yep, okay. Again, no exam questions that I had for that one, but I'm sure I do for this one. How would you go about doing question 5?
So would you do? So just say the number is 4. If you add 2, it's 6. So then you square it, you get 36, and that's greater than just 4 squared, which would be 16.
Yep. Let's just find some counterexample. Let's see. How do you do question 6?
Would you expand the left-hand side?
No. Focus on the right half of the question.
I'm not sure what to do with that.
What are all the positive integers less than 7?
6, 5, 4, 3,
6, 5, 4, 3.
2, 1.
Yep. So just sub each of those in and show that it's true. So I would just do 2 times 1 plus 1 and show that that's greater than 2 to the power of 1 plus 1, which is...
And then you sub in 2.
Yeah, and you just use your calculator.
Yeah.
So that's proof by exhaustion. Let's see. Let's just do... how would you do the very last one?
Is this like a counterexample or?
True that if n is an integer,
Or exhaustion, because it has to be between 2 and 7.
Yeah, I'd say that's exhaustion.
So you do 2 squared plus 2 gives you 6. That's not divisible by 4. And then you just sub in all of them.
Yeah, you get the idea.
Yeah.
Yes. Question 8. Just make it, in terms of 0. So just expand it, make it greater than or equal to 0, and then just solve it, I think. Prove that, yep. And then Amir claims that this one determine what... Yes, Amir, I'm sure. How was that for you?
Good, thank you.
How do you feel about methods of proof?
Fine.
Yep, that's about as good as it gets with proof.
Yeah.
So any topic I did have my exam questions ready. Oh no, these were from earlier. Any topic in particular you want to do next time?
Not yet, but I'll let you know if there is.
Okay. Any questions for me in general?
No.
Alright, well done, Keelan. You did great. I look forward to talking again next week.
Yeah, you too. Have a good week.
You too. Goodbye.